Okay, here's part 2. We're going to build RAM. Okay, first we need our output lines. Each column of RAM should be outputting to the same value, so we're going to need to have outputs to share to. We are going to build the RAM slightly above. You can see finish point over there. And each RAM looks like this. It's a nice little T shape. So we're going to build a 3x3 bit piece of RAM. This is a modular design, so you can easily replicate it by using the copy and paste commands found in both vanilla and our modded Minecraft. In fact, if you are on the RAM section for the final project, copying and pasting this is extremely helpful. So, since we have a 3x3 bit array, we're going to need 3 output lines. I'm so challenged. Okay, now we are going to build our D flip-flops. Notice that we're storing the inversion of the state, which means that we're going to need to correct that later. We use the D flip-flop design from the previous video. It's just like this. Okay, we've got our 9 D flip-flops. Now we need to hook them up. So, first things first, we're going to need to have our gates on the Ds all connected. Because you're writing to one particular row at a time, you need to have them all controlled by the same input. Okay, great. We have our write lines. Notice that if I turn one of these lines on, say connecting it to a lever here, it allows for whatever state you currently have to be written. Otherwise, it blocks. Well, you probably should hook these up to a torch, so that's actually what's happening. So now we'll have the levers set to block when no output's being produced. This is slightly more true to the actual design for the computer. Next, we need to have the outputs. Or the inputs is actually a better first one. So let's go ahead and build the input lines. We want each column to share the same input. So every first entry in the column should come from the same input, and the write line should be used to select which line you're currently writing to. Here's one write line. And here's another. Let's toss our last line down there and then get to the next part. Fantastic. So we want our inlines to be writing 1 by default, because this turns the output off. We only want the input to be turned on in the situation where the input is. when the input's on, so that make that off. Now, you might notice a problem like this. Let's say that we write to only 1. Let's say we write to 2. So we're going to write times set day. Okay, let's say that we write this digit to the top gate right here. So we're going to turn our blocking back on. And we're going to unblock the top input. Okay, so let's write to it. Rewrite that. Fantastic. Now you can see we've written to one of them. Now let's write to this one. Well, you can see that we're not actually reading from anything right now, but we're still outputting what's in them anyways. That's not good, so we're going to need to fix that. The way we do that is we build another line that controls read access. Actually goes across here. The biscuits are done. Fantastic. Alright, so the line goes across the top here. That's a little weird. One, two, three, four. 1, 2, 3. Huh. Did I put an extra on somewhere? Oh yeah, I did. Yeah, there's a slight error here. This row should be built directly on top to minimize space. It'll work either way. In your design, go for the design here where it's more compact. What this does is it forces these inputs to all be off unless the read switch is flipped, which is exactly what we wanted. Yeah, this is a mistake, but it still works. So make it what you will. Yo, yeah, messed up here too. This line right here should be right on top of it. Again, to minimize space. But again, it works, so you kind of have creative license there. And our last row. Yeah, so I'm going to go back over to the finished design from before and demonstrate this. Alright, so what you have here is a fully complete ROM. This one's actually more compact, which I was commenting on. Notice that these are only 3 blocks.